So I want to talk about exponential growth and decay today. And the exponential growth that I want to talk about has to do with the base e. Okay, so for growth, we can have it look like, right, our f of x is equal to, we can have, well, the basic equation, you have e to the power of x. All right, so and then we also said, actually, before I talk about decay, let's stay on growth. So it's e to the power of x. This is what we discussed in a previous video. So we have e to the power of x. This is a growth, but I can manipulate this in a way that I can have a constant in front of my a, all right, or in front of my e. Okay, so I can have a constant in there. I can also have, in front of my x, I can also have a value which we'll call k. Now, let's go ahead and erase that. Instead of calling it, we have our a here, we can have ae, and then e is to the power of k times t. All right, this is exponential growth when we have base e. So basically what I did is I took my t, and instead of making it x, I made it t. All right, now it represents, a represents the initial value. All right, so if you're looking at a population problem, then you're probably looking at, you started off with 100,000 people. Right, so that's what you would put for your a value. E is a constant, so we don't need to touch that. T is the time in years. Right, and then we also have k, which is our constant. This is a constant, and this is the rate of continuous growth. Continuous growth. Okay, now this is exponential. Wow, okay, that line though. All right, growth. Now so let's analyze decay. Decay is if I have f of x is equal to, everything is the same except it's negative k times t. All right, my a value is also the initial value, so it's the same thing as the other one. My t is the time in years. K is the constant. All right, e is, of course, your 2.71, the mathematical constant, e to the power of. Right, and then this is the rate of continuous decay. Whoa. Rate of continuous decay. Okay, so the rate at which it's lowering. So if you look at your growth and the decay, the exponential functions, you'll see that growth is a positive exponent and decay is a negative exponent.